Today, we frequently see futuristic visions of this in science fiction movies and TV shows such as Star Trek, where computers can literally read your thoughts. Futurists call this technology wetware. Wetware refers to linking the human brain to computers.
Though still in the realm of science fiction, new technologies are now beginning to explore the ultimate human-to-machine input device, the brain. Another company working on the same type of technology is Biocontrol Systems of Palo Alto, California. They've developed a device called the eye controller. It's similar to the headband from IBVA, but can interpret eye and facial movements in addition to brain waves. Here's how the device works.
This may look like an ordinary video game user, but actually he is using the latest in human-computer interface technology. What we are watching is a video game controller that is completely hands-off. This game is being played with eye movements only. The attack ship in the game is moving in response to the player's eye movements, so wherever he looks, the ship immediately moves to that position on the screen. In addition, a slight muscle twitch, for instance from the jaw, is programmed to fire the ship's rockets. Thus, the player has complete control of the game action simply by making subtle eye and facial movements. Now, when Ben turns toward us, we can watch the effect of his eye movements. Left, right, up, and down eye movements move the object in a corresponding way on the video screen. Physiological signals are picked up by sensors in the headband, and eye position information is sent to the computer in the form of commands to move the game object in a desired direction. Just as a video game can be played with eye movements, the eye controller can be used as a computer mouse, and therefore enables utilization of menu-driven software to do word processing or graphic design simply using eye movements. Users have commented that this is a much more natural and intuitive way to move virtual objects around on a video screen as compared with pushing a mouse around on a desktop. The eye controller eliminates the need for a surface for the mouse to operate and also eliminates muscle and back problems often caused by uncomfortable mouse positions on the desktop. To highlight the applications for the eye controller, or icon as we call it, in addition to video games and word processing, we have already begun exploring avenues for bringing the icon to physically disabled users. Since eye movements only are required, people with movement impairments or even complete paralysis can use computers or play video games with the ease of normal users. Indeed, in the virtual world of electronic objects, all users become equal using this type of physiological controller. And speaking of virtual worlds, the virtual reality community is very excited about the possibility of using the icon as a new way to interact in the virtual environment. In trials with Sensate Corporation in Sausalito, users were able to fly through virtual terrain simply by looking in the direction they wish to go, truly a dreamscape experience. The eye controller will also be useful in any environment where an operator cannot manually interact with the computer keyboard. On a factory floor, for instance, the icon will allow the operator to move freely about the plant, controlling functions from a menu on a large screen display at some distant point on the production floor.
Biocontrol Systems scientists have incorporated the icon into yet another device called the BioMuse. The BioMuse is a biocontroller that performs many application-specific functions. It receives data from 4 main sources of electrical activity in the human body: muscle movement, eye motion, brain waves, and EKG signals.
The system then amplifies, digitizes, and processes these signals to extract the desired elements of the biosignals. Then it maps the results to some desired output code to control virtually any digital interface device. For example, a mouse cursor on a PC.
The BioMuse has a total of 8 input channels with programmable gains and filters that can be configured to process any bioelectric signal. This is where the icon comes into play. It's used as one of many devices that collects biosignals. Muscle sensor bands are added that can be customized to interpret a large range of muscle signal intensities and durations. These signals become control signals for electronic devices.
As mentioned before, one potential application of the system can be for the physically disabled. Some handicapped users may have residual muscle signals in the extremities which produce no movement. But these signals are still usable by the BioMuse to map control code. So a physically disabled person may someday be able to control a PC through the BioMuse.
Using a musical instrument digital interface, or MIDI, the system can also be programmed to process dynamic aspects of muscle and eye signals that can be mapped to control virtually all aspects of a music synthesizer. Muscle tension, for example, can be programmed to note number and volume, enabling different amounts of exertion to change pitches and sound levels from a keyboard.
BioControl has licensed BioMuse units to various medical and high-tech research centers worldwide to support the development of further applications and specific products utilizing biosignal processing. Ultimately, the company hopes the BioMuse could allow users to control computers through thinking. So someday, a version of wetware might remind you where you left your car keys so you can concentrate on more important issues like where you want to go.